to you is this function with this domain, and this is the codomain, the real line, complete real line. And the function is defined like this. Now they are asking you whether the function is odd, whether it is even, 1, 1 or onto. So we have to check it one by one. Okay, let's focus on whether it's odd or even. What do you do? So you just check, instead of x, you put a minus of x. Okay, and see whether it is coming out to be f of x. If it is f of x, it's even. If it is minus of f of x, it's odd. Okay, otherwise neither. Okay, so let's see. Now instead of x, you are going to plug in a minus of x. What is your secant function? It's an even function. So secant of minus x is secant of x. Tan x is an odd function. So tan of minus x would be minus of tan x. So I'm just directly putting it here like this. Now you have to do a little bit trigonometry here, because now secant x minus tan x. Do you know it is 1 over secant x plus tan x? If you know, good. Otherwise, you can do one thing. You can just multiply secant x plus tan x in the numerator and the denominator as well. Secant x plus tan x like this. Okay, you can do that, right? Yeah. So whole cube. Now what happens? Like this multiplied by this. This is secant square x minus tan square x. And what is that? Yeah, 1. Secant square x minus tan x is 1. And in the denominator, you have secant x plus tan x. Still not there? So what do? You use the property of log. Okay, so this is log 1 minus log of the denominator. Okay, so log 1 is 0. So what do you end up in getting? Minus log of secant x from the property of log this. Okay, now you can just take that minus outside. Minus 1 cube is again a minus. So you get this secant x plus tan x, right, whole cube. And now you know, right, what is this? This is minus f of x. Okay, so what does that mean? That the function is an odd function. So let's take this. Okay, the function is an odd function. Now let's focus on the next one, whether it's 1 1 or not. How do you show whether its function is a 1 1 or not? You know what's 1 1, right? So if a function is 1 1, let's say if I draw something like this, okay, it should pass a vertical line test. Like if I draw a vertical line, it should cross the function only once. Okay, that's the 1 1 function. Now, the easiest way to show that function is 1, 1 or not is just show that it's increasing function. Okay, if it is increasing, of course, this will definitely happen. So for increasing, what do you need to show? That the derivative is positive, right? Okay, now if you look at this function, it's composition of so many functions. Like if I just break it down, so my g, let's call it gx. The very inside function secant is x plus tan x. Okay, that's gx. Now, what's the more outer one? Let's call it phi x. That's log x. Okay, so phi x and gx, if you compose them, you get log of secant x plus tan x. There is another function, right? X cube. Yeah. So if you compose like like this, phi of psi of g of x. Okay, that's your function which is given. Okay, this is equal to f of x. Now, what's the property of composite function? Yeah, you already know that log function is increasing in its domain. This is also always increasing. Now, if you can show that just this is increasing, you're done. Okay, because the composition will be an increasing function. So no need to take the complete function. You just show that g is increasing in the domain given, and you're done with. Okay, so let's try figuring out what is g prime of x then. Okay, so this is your g of x. Tell me the derivative. Secant x derivative is secant x tan x, and tan x derivative is secant square x. Okay, now normally it is difficult for us to see in terms of secant tan. Let's convert it into sine and cos. So I get sine x, okay, 1 over cos, and cos square x. Okay, just look for yourself. Okay, if you're getting this, right, you're getting that. Okay, so what is happening now? It is secant x plus 1 upon cos square x. Is it positive? Yeah, because denominator is all the time positive, right? And numerator, is it positive too? Yes, because sine x lies between negative 1 and positive 1. If you add a 1 everywhere, what happens? This guy is lying between 0 and 2. Okay, so it's always positive. So you have just now shown that this is all the time positive. Okay, that means your function is an increasing function, hence it is 1 1 also. Okay, so this is also done. Now what is remaining, whether it's onto or not? Okay, onto means what? Onto means whatever is the codomain, range is the same. Range is same as the codomain. So what you have to look for? You have to look for range of this whole function, whether the range is the whole real line, that is negative infinity to positive infinity. Yeah, so let's go by one. Okay, let's try to figure out what is the range of the inside most function. Okay, like this function, the one which we are working right now. Secant x plus tan x, what is the range? You have already shown it is increasing, right? You have already shown that g of x is secant x plus tan x is increasing function, is increasing. Okay, now what do I need to show? Is increasing in this domain, right? If let us figure out at negative pi by 2 what's happening and at positive pi by 2 what's happening. That would be the range of this function then. Okay, so let's see. So how do we figure out? Let's figure out negative pi by 2. Okay, so x goes to negative pi by 2 secant x plus tan x. Can I substitute the value negative pi by 2? Okay, if I substitute, what's happened? Sine of negative, it's an even function. Okay, so you get positive infinity. What is tan of negative? That's negative infinity. Infinity minus infinity, that is undefined. Okay, indeterminate, so we can't do that. Okay, so let's figure out what's the limit. Let's again convert it into sine and cos now. Okay, let's do that. So if you convert it into sine and cos, you will end up in getting this, right? Secant is 1 over cos, this is sine over cos. Okay, now what do I do? Okay, again 0 by 0, right? So let's apply L'Hopital's. Okay, 1 plus sine x, what's the derivative? Cos x. Cos x derivative minus sine x. Can I plug in now? Absolute yes. Cos pi by 2, negative pi by 2 is 0. And sine of negative pi by 2, that would be this. Okay, so I am getting a 0. Okay, so at negative pi by 2, secant x plus tan x is getting 0. Okay, now also let's look at what's happened at the other end, like positive pi by 2. What is secant x plus tan x? I can just plug in, right? Yeah, here I can plug in because secant pi by 2 is positive infinity, so is tan pi by 2. So I get infinity plus infinity is always infinity. So what did you get? You got range for this is 0 comma infinity, right? That's what you got. Range for this function is 0 comma infinity. Okay, now look at the composite function, what's happening. Okay, when you take a log for that, basically let me write in short what do I mean. If you take a log, okay, on something which has range of 0 comma infinity, what do you get the range? Yeah, negative infinity to positive infinity, because log is defined for positive values. Okay, log looks like that. Okay, can you see the range is what? The range is whole from negative infinity to positive infinity. That's the range when you take a log of that. Okay, now there is another function psi also. When you take a cube of that, what happens? It doesn't change, right? Okay, if you even take a cube of, this is not a way of writing, just to express that. Okay, even still you get the range to negative infinity to positive infinity. Okay, so in short, what do we get? That's the range. That's a complete real line. So yes, your function is onto as well. Okay, so we are done with this question. Let's do another one.